Okay, we will start from where we left in the last session. So in this data pipeline building, um, so we just saw the data source where we have a simulator to generate um, the e-commerce data as a record or messages to the Kafka topic. Now we will see how to consume this data from the Spark streaming side for the purpose of data ingestion, where we might write the raw data, whatever the JSON message we consume, right? We will write the raw data in HDFS, and we'll do data processing. In terms of data processing, we'll make some simple aggregate and write the data into MySQL for the visualization or publishing to the dashboard. So these are the two things we are going to do with the Spark streaming, Spark structure streaming using the Spark structure streaming. Sorry for my throat. Okay, so okay, fine. Let me open my code. So this is the there's a project called in this our e-commerce real-time case study folder. We have a project called real-time data processing. So this is the program for the Spark structure streaming. Okay, so if you look at the initial portion of it, we just import the respective packages from the PySpark package. So the important class we need to import is the Spark session. Okay, so Spark session is basically a you can think of as a connection object. Okay, so in database terminology, so in Spark, this will help us to establish the connection between Spark cluster and the program which we write. Right. So this program, whenever we write the user code, right, they call it as driver program or user code. So you might know the different terminologies in the Spark framework, right? So when you run a Spark program, there is a driver process which gets created. Okay, which is basically the program, the driver process, the one which runs this program and generates something like DAG, direct acyclic graph, and which submits the DAG to the cluster to um, execute this DAG by the executors in the worker nodes. Workers node is nothing but one of the server in a cluster, right? Which the driver also negotiates the cluster manager to acquire the executors to run this task. So that's how the architecture is point of view. So this.
Pari, sorry to interrupt. So as you mentioned, so first Spark session will give the instructions to the driver, right? So the driver will communicate to the executors and the core to perform the task. Am I correct?
Yeah, correct.
Okay.
So yeah, though yeah, which for first year question, then yeah, I'll.
Okay.
No, you said you complete your question.
Yeah. So now we have driver memory and executor memory in that. Right. What will be the difference and how means when we are submitting when we are submitting the job? Okay. Do we need more memory for the driver or more memory for the executor? And what will be the difference between those two?
Okay. So if you look at we will take this common architecture and then we'll go with the okay. So this is the typical Spark architecture diagram you see everywhere, right? So here the Spark context you can think of as Spark session object. Okay. So earlier, before Spark 2.0, we were using Spark context directly, which help us to negotiate the cluster manager to get the resource, and then the driver program will launch the executors here to perform the task, right? Then from after Spark 2.0, still we are using Spark context, but it's wrapped inside the Spark session object. So that's how the architecture little changed. When you say, so there are two important processes in the entire our application execution lifecycle. One is the driver process. Whenever we run our code, okay, so the where you have a Spark session object creation, right? So if you look at here, this is our Spark session object creation. Okay, so this is where we create our Spark session object. So this considered to be a main method of our program. So that time the driver process creates. Okay, the driver process creates, and it creates the Spark session object in this case. So you allocate, when you submit a job, you allocate a driver memory and executor memory. So driver process does not do any computation. Okay, and the executor is the one which is going to do the computation, right? Whatever the computation you make, whether we do uh, like complex logic, if you write, or the data is, that data is going to be processed in a larger data set or small data set. Every time the execution happens in executor. Okay, so driver process only kicks off the or it submits this task to the executor. It actually collects the output. The driver process needs memory to manage your job. Okay, only the managing a job and initiating the job or scheduling the job, these are the three activity, and then it collects the output. So with respect to those activity only, it needs some memory. So computation is the one which is done by the executor. The memory you allocate uh, uh, executors will be allocated to the executor. Why we sometimes we need a more memory for driver whenever you collect the output, larger output, if you want to keep it in a driver. Say example, if you want to collect some output and in the driver program, then you need a more memory. And in the executor memory you allocate, it's going to be individual executors. You always allocate executor memory per executor, but the driver is a one plus. Whatever memory you allocate only for this driver process. And then the driver process, okay, the driver is actually a single point of failure. Okay, so because there's only one driver which is kind of coordinator, that's how the memory will be allocated. Okay, if you compare um,
Mhm.
the memory you allocate for driver with respect to uh, what kind of output you are going to get it. If you are getting in the driver, if you are writing into different storages, then the driver memory will be not much memory will be allocating.
Okay, so you mean that if I want to do some other process after execution, see, if the output need to be collected and processed to another Spark session without storing anywhere, then I need driver memory more. Am I
So
correct?
yeah, whenever you collect output in the driver process, say when you say
I mean, I
DF,
just want to understand that wording, collecting of output in the driver memory.
uh,
What does it mean?
uh,
Means,
so I will say
can you
there,
give
there
an
is a,
example?
yeah, there is a method called show, right?
Right.
If I have data frame, when I say show, right, that's
Mhm.
basically a collecting output on the driver side.
Okay.
If there is a RDD and you say RDD dot collect,
Yeah.
that's one of
Okay.
the method, right? So
Okay.
these are the methods will bring the data to the driver.
Okay.
Okay, so it dumps the output result to the driver. that time you need a more memory because it has to that those data has to be uh, get into the driver's side.
Showcased into the front end when we are running our debugging mode.
Correct, correct.
Okay, got it. So moreover, when we are doing a debugging and displaying the output in the runtime,
Yes.
That at the time we may need more driver memory.
Yes, yes.
Okay, got it. Thanks for the
Okay.
clarification.
No problem. So we import necessary package, and we also going to import this through built-in package. We are also here, we are using configuration file. It's almost same code snippet which we used in the Kafka producer. So we are having Kafka details in one section in the configuration file, and another section we have MySQL details, right? So which I think last class we discussed. These are the MySQL details we need.
So what is that config parser do?
Config parser basically help you to parse the configuration file and retrieve the data. So this is the configuration file.
Okay. Okay.
Yeah. So if you have if say example, instead of this, if you have a JSON file, right, then use JSON package to parse it. It's just a parser to retrieve the information from configuration file. And so we create a configuration object, parser object, and then use the read method, okay, to read the configuration file. Before reading, say example, if you say configuration object dot sections, it will not have any information because you are not read the configuration file. And so the sections will show, object dot sessions will show these two, like MySQL and Kafka. And inside section, whatever the key value pairs you have, so you can access the values based on the key. So you always access the configuration object dot get of, pass the section name and the key name, so you will get the value. So first we are retrieving the Kafka information here, and then we retrieve the MySQL information. And also MySQL we have a tables, two tables, sales by card type and sales by country. So just kept very simple aggregate. We can build the same even complex aggregate also. You can build the joins as well. So all things we can do. First, I just kept simplicity. Then we can just enhance the functionality later. I'm sorry. Now and also we are building the JDBC URL. So whenever we want to connect to the RDBMS database, right? In this case, MySQL, if it is a Postgres or any other thing, then you might need the same JDBC format. You just may change you might have to change the, instead of MySQL to Postgres or MS SQL for the SQL Server and Oracle. Maybe slight variation will be there, the JDBC URL structure, but the concept is same. So we are going to integrate with the MySQL for writing the data uh, by writing the aggregated data in the MySQL, and also we are going to integrate with the Kafka to consume the data from the Kafka topic, right? So let me show you one diagram. Okay, so if we have a, okay, you will have a Spark success streaming, and you will have something called sync, or you can call it as destination, target, whatever you call it. So in the Spark streaming terminology, uh, okay, so this is nothing but source, right? This is nothing but source. The source can be anything. So or it can have some file source. there anything else? You will have so Kafka streaming will consume the data from the source and write the result into sync, something called sync. So sync can be of again anything. So in this case, we are using RDBMS, which is MySQL here. You can enable a file. So even if you want to write result output into Kafka, we can do that, or some kind of um, different TCP socket is there.
So multiple targets in parallel also we can do.
Yeah, we can do. We just have to initiate the sync, then it will write. And if for anything, so even the NoSQL also we can write. We have to for NoSQL, there's no out of box sync there. We have to write our sync. Okay. Even for MySQL also there is no out of box sync.
Okay. So this when we are putting the Kafka as a sync, that means for another application it may be a producer.
Correct. It may be a producer. Correct. Exactly.
Oh, thanks.
Okay. Now, so this is now the Spark structure streaming. So you can actually also go through this official documentation where it will say what are the sources available out of box, right? Structure streaming. So input sources, so we can consume from the file source, Kafka source. These are for testing purpose, socket source. Okay, so if you want to consume from different databases, we have to write our own sources. Okay, and there is a custom source, right? Also, and if it sync, right? So sync will be in the output sync. So again, you can write the data into the file sync, Kafka sync, and if you want to write into different storage, right? Like example, like in our case, MySQL, or it can be NoSQL database. We don't have a out of box APIs. What we can do is we can actually make use of the for each, right? So for each will help you to iterate your the final stream data frame. You iterate it inside. You can when you iterate um, for each, right? It's kind of iterating your data frame. Then call you can have a method which will write the data into target, and you call the method in the for each. Okay, so that's how we can do the customization. And there are other testing purpose things are there, like writing the result into the console just to want to display your data in console. Even for memory sync also there. So this is the high level Spark streaming. Now, so in our case, we just going to create a Spark session object. So Spark session object, we use the builder method to, I think this I'm not telling because this is just simple Python syntax. I think people will understand. So inside this if block, I'm writing the all the Spark code. So Spark session object we are creating using the builder method. We pass the master URL here. So as a local, then we will pass later point. We'll pass the Spark standalone cluster and also yarn. Once we create a Spark session object, we can set the log level. Okay, so when you run a program, it will just show the log4j log, right? So it will by default it will show all info, warning, error logs. Since it's a streaming application, right? It will run for 24/7. There will be a lot of logs will be generating. So if you want to just see only the error logs, then you can just enable using this property. Like I told you, Spark context, still we are using Spark context, which will be wrapped inside the Spark session object. How do you access the Spark session object? The Spark is nothing but Spark session object. That's what the name I kept it here. It can be anything. So dot Spark context, and you can set the log level as error. Now the important steps comes where we are going to consume the data from Kafka. Okay, so if you are familiar with the data frame operations, right, where when we use the data source APIs, like reading from any file source or reading from RDBMS, anything, you say data frame dot read dot format of CSV or MySQL, whatever you do. The same fashion we are using in the streaming application also. Only difference is Spark dot read stream. Instead of read, the data frame we use data frame reader. We are using stream reader here. So Spark dot read stream dot format of Kafka and provide the Kafka information. What all you need to provide? The bootstrap server, which is the host name of Kafka broker, colon the IP, the report number. And then here subscribe is nothing but you need to pass the topic and starting offset from which position you want to consume it. When we say latest, we say latest message will be consumed from the Kafka topic and the load. So this will return you the data frame. So this data frame is a stream data frame, which has very little limitation compared to the batch data frame. Okay, so because it's going to consume the data whenever the data arrives, and it's going to have the data in the data frame, and we will be processing for the every whenever the data. So there are two ways we can process this data in this data frame. One is whenever the data arrives to this data frame, you process or you wait for a certain period. So that's called batch interval. You can set in the later point of view. So based on the batch interval also, that whatever the data gathered in this stream data frame, we will be processing it. All right. And then, okay, so now when you run this program, okay, when I say Spark submit and provide master URL, and then the program, this program will fail because it needs the Kafka connector libraries. Okay, so that's a so example. I'll come to this part. So when we say Spark submit, sorry, is someone asking question? Is someone have any question?
No,
Okay,
I think someone unmuted and talking.
Sure, fine, thanks. Okay, again, if you this meeting disconnect, use the same link and connect. Fine. So we pass the master URL. Then you see there's a property called hyphen packages. There we have to provide the Kafka connector details. Okay, so this is the Maven coordinates for the Kafka. I think we discussed last class. Okay, fine. So we have to provide the group ID, artifact ID, and the version. And if you have multiple connectors to be downloaded, you just put the comma and provide the Maven coordinate. The Maven coordinate format is group ID, artifact ID, and the version. If you want to manually, so this will automatically go and get the respective jars from the Maven public repository, or based on the your proprietary repo Maven repos. Okay. If you want to manually have your jars and submit to the Spark submit, then you can use the hyphen jar property and pass the respective jars with the comma separator. And also we are going to provide the configuration file, then finally the program. Let's come back to our code.
That suppose that if I want to pass any specific class to Means that is also possible, right?
So
But I
basically,
don't know why the class is being used actually.
which one
In
class?
which, yeah, in which case we need to pass the class actually, class for the
S-
jar actually,
so
driver
basically,
class.
yeah. So basically, when you run this is running a PySpark application, right? When you write,
Yeah,
when
okay.
you run a Scala based or Java based Spark application, so you will build the jar, right? And you will
Yes.
pass the jar. So the jar might have different classes. So you have to
Okay.
instruct uh, the Spark submit engine which class having the main method.
Okay. But
Okay.
sir, actually
Yeah.
means I think I talked to you regarding that MongoDB connector, right?
Yeah. Correct. Correct.
So what happened in that case? My Spark version is 2.3
Hmm.
and MongoDB version is 4.4.
Okay.
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 Yeah. So when I was using a jar,
Hmm.
so suppose that I downloaded one jar
Hmm.
and that was not helping me actually. So I got to know I
Hmm.
needed some Java jar also. So in that case, I
Okay.
gave the driver class actually.
Hmm.
And that is being used because that my Spark version is 2.3 and the Mongo version is 4.4. So I was having one class or
Hmm.
from there, and that class is being used from that jar actually.
Hmm.
So
Hmm.
as per my understanding, that is a Java program, so I was using driver class, right?
Hmm.
Okay, okay. I got the now. I got it. Okay.
Okay. Those version dependency actually, yeah, sometimes you face the issue, but you just actually there actually there's a page right in the uh, Spark MongoDB connectors page, official documentation page is there. There you can refer what is the respective Spark version, what is the connector version. Say example, specific Mongo version you are using. So you can refer there.
Mhm.
Actually, there is a documentation page. Probably I will get it sometime and I'll share. So there you can use the respective for this particular connector. What is the Spark version you need to do, or what is the Mongo version you need to do? Use.
Okay. Yeah, yeah.
All right. Thanks. Thanks for informing us. Okay. Okay. Now, okay. So we publish the data to the Kafka topic in the producer side. So when you consume, uh, your data frame columns will be of you will have these columns. You will have a key column, value column, value column and topic, and then partition, offset, timestamp, and there is one more column also called timestamp type. Okay, these are the columns. You will find it in the data frame which you formed based on this data source API for the Kafka, right? Um, Actually, your whatever the message or record you published in the producer, right? That will be persisted or be having it in the value column, and the type of the value column will be a byte array, because when it comes via, because we in the producer, right, you see the JSON string we convert it into byte array uh, here. So we pass here the dictionary object, right? When we pass the dictionary object as a message, so we have a value serializer which converts the uh, dictionary object into string. The dumps converts into string, and it is encoded, actually serialized to byte array of the UTF-8 standard. So the byte array comes via your network. So when you consume also, it will be a byte array. So you have to do the casting, and also we have to extract the message and form a data frame columns. That's we have to do by ourselves. So that's the reason I am doing data frame dot select expression. There is a function called select expression. You pass the kind of SQL expression like cost. There is a function called cost. Pass the value the column and as a string. So it is going to cast your byte array column into string, and we just take the timestamp column. I at least at the moment we don't need this other columns like partition column, topic column, other stuff. and you get the data frame. From this data frame, then only two columns will be there, one value column and timestamp column. Now the value column it's a string column which contains your JSON message in the string format. Okay, so we have to convert, you have to extract that JSON column and convert it as the columns in a data frame, so that you can perform either data frame operation or register as that data frame and perform the SQL operation, right? So how do you extract the JSON string and make a different columns? So if you want to extract your JSON string, you need to have a schema for that column, right? The what is the schema that JSON structure has? So we need to perform we need to prepare the schema for your based on the JSON structure. So schema prepared based on the using the struct type. Okay, because our JSON structure will be of this type, right? So this is our JSON structure. So you'll have order ID, product name, order product name, order card type, and so on. So you based on this structure, you prepare. Struct type is the data type which is used to for extracting the, or just instructing that you are going to extract the JSON structure. Okay, struct type means this whole. And then inside each field, what is the field you have in the JSON, and provide the respective data type also. So we can actually, for now, we just providing all type as string type. Okay, so order column, order product type, and others, so on so. And then when you, in the next step, what we say, the data frame which we formed the earlier, and select of from, there is a function called from JSON. Okay, so if you want to extract the JSON string of column, and you have to pass the column as well as the schema for from JSON function. Okay, and then I'm going to create this new column as orders, and just get the executive column timestamp. Okay, so this is one column which is a value column. We are extracting JSON message, and then converting into new column name as orders. So just renamed, actually it's, we are aliasing the orders and the timestamp column. This will give the new data frame. Okay, so we have only 1 minute left. We will disconnect and connect with the same link. Then I will explain you in detail this. I'm just stopping this. Please connect the